Hey everybody, this is some homework help with 2.1 from Algebra 2. We're just going to go through and I'm going to kind of demo or give you an example of what my expectations are for each of these and help you understand what we're dealing with there. So the first thing we're going to look at is actually question number 6 here. We're going to take a quick peek at question number 6. And it says, first, identify the domain and the range of the given relation. And I could do that as a separate thing. It says, then represent the relation using a graph and a mapping diagram. I'm just going to use a mapping diagram. I think it's going to be good enough for us to understand if we just do that mapping. So what I'm going to do here is I'm going to state my domain in a column, and I'm going to go ahead and state my range in a column as well. So make this little table of domain and range. I'm going to start in my domain by listing my x values. It does not matter if you do it from least to greatest or greatest to least or in any particular order, but do not list the same number in the domain more than once or in the range more than once. So for instance, my first x value is -7. My next x value would be 2. My next x value would be 1 and then -3. Notice none of those are duplicates. If I had another ordered pair with a -3 as my x, I would not write it more than once. My range over here is going to be my y values. Again, the order doesn't matter. Typically, I'm just going to keep it in the order that I kept the other in, which is 4, then -5, then -2, then 6. There's my domain. There's my range. All I have left is to draw the mapping. What I want to do is indicate which domain value is associated with which range value. So let's draw an arrow that -7 leads me to 4, that 2 leads to -5, 1 leads to -2, and -3 leads to 6. This is what my expectation is for you to do on 3 through 8. That being said, I want to make one adjustment here. I'm going to change the problem just so you can see what happens if we had one more value that didn't work with our information here. So let's pretend that we also had a 2, let's 2, 4. As another ordered pair. Okay. Actually, we're going to change this. 2, let's do 3. So say we had 2, 3 as an ordered pair. Well, I already have my 2 on the domain, but I don't have a 3, so I'm going to need to put a 3 down here. I have to draw a mapping that shows that 2 can lead to -5, but it can also lead to 3. The fact that this x-coordinate has a choice indicates that this is not a function. So originally, number 6, without the 3 there, it is a function. And I want you to tell me each time if it's a function or not a function. But here, if I add that extra ordered pair, where I'm using 2 as an x value more than once, I would see that I'd have a choice. And that choice would mean not a function. Okay? So you're going to create those mappings. Anytime an x value gets repeated, you're probably going to say that you do not have a function, okay? If you want to be specific, if you've got a repeated x, then yeah, it's not a function. And you'd see that indicated. Look, my little thing's going crazy. Okay, the next thing we're going to do is we're going to look at 10 through 13 are all about, is it a function or is it not? If you look at these, what we're asking is there an x value that goes to more than one y value? So for instance, -6 only has one place to go. -4 only has one place to go. -1, one place. 2, one place. That is a function. But so is number 13. Do you see -8 only has one choice? -4 has one choice. 0 has one choice. 4 has one choice. It's about 2 arrows coming from the same place that indicates this idea of a non-function. On questions 16, 17, 18, 19, you do not need to draw the diagram, but you could. What you can do instead is look for what would cause that issue to happen in the diagram. It has to do with duplicated x's. So on question number 19, I'd be looking at my x values. Do any of the x values repeat? If they do, I would say it's not a function because this x value is used more than once. So in number 19, you should be able to see that negative 1 occurs as an x value in the first ordered pair and in the last ordered pair. That tells me it's not a function. If I didn't have that, I'd say it is a function. All the x's are unique. The next type of problem that we're going to work on is this vertical line test. A vertical line test is basically the same thing we've been doing, but visually, and hopefully you caught this in class. The idea is that if I were to draw a vertical line anywhere on this drawing, okay, let's go ahead and draw that there. Let's see if I can pick it up and move it. Yeah. As I slide this from side to side, does the blue graph ever touch my pencil line more than once at any given spot? The answer is no. It never touches the blue line more than in one spot. That makes it a function. If I can find an example where it touches the blue graph more than once, then I'm finding a case when it's not a function. Okay, let's go ahead and delete that. So that's the idea of the vertical line test. It's a way where if I have a drawing, I don't have to go through and look at the numbers. I can just look at the basic idea from that. Hopefully that's enough to get you through the homework and answer some questions. Anything else you have, bring them to me. Shoot me an email or a message on Teams. I'll try to respond to those as often as I can. All right, we'll see you.